Good morning, good afternoon, everyone. I want to start out and tell everyone thank you for joining the webinar today. It is our first one for the Trenchless group, and I'm really hoping to educate everyone on a little bit of what we've got going on. Not only the joints that we've had a lot of success with, but some of the things we have coming up that are exciting, as well as give you an overview of how our casing is made and how it is put into the field, and then also the project management approach that we've really taken this year. Today's webinar, Smarter Steel Casing, is basically how to maximize trenchless efficiency and performance with Permalok press fit joints. So my name is Brian Swanson. I am the sales manager for the Trenchless division of Northwest Pipe Company, Permalok. I've spent the last 2 years here at Permalok doing sales and really helping with the project management side of things as well. The previous decade plus before I was here, I was actually on the Trenchless contractor side of the business. I've done HDD installs, auger boring, pilot tube, microtunnel, large diameter tunnel bore machines, pretty much any and every type of trenchless installation, I've done it. In my time on the contractor side, I installed thousands of feet of Permalok. So when I came over to this company, I already knew the product. I knew how well it worked. I knew the efficiencies of it. So it was a fairly easy transition. But I've been able to use my experience on the contractor side to really help me on this side of the business. Next, I want to introduce our sales coordinator. Her name is Presley Heitzman. Presley, if you want to jump on and introduce yourself to everybody.
Hi, everyone. My name is Presley Heitzman. I'm your sales coordinator here at Permalok in St. Louis. I've only been a part of the team for just a few months, so I'm still fairly new, super fresh out of college. But in my role, I handle quote requests and help to keep communication open and constant with our customers. I work closely with Brian here and the rest of our internal team. You'll meet a few of them in a minute, to help make sure our customers get the right information in a timely manner regarding all project needs. Please feel free to reach out whenever for your next quote, and it was a pleasure to meet you all.
Thank you, Presley. And next, I would like to introduce Tim Connors. He's our project supervisor. Tim, if you'd like to introduce yourself.
Hey guys, my name is Tim Connors. I'm Permalok's project supervisor. I've been with Permalok here for about almost 5 years now. As the project supervisor here, I'm going to basically be taking you from start to finish. I'll be taking care of all your submittals. Once the quotes come over, I'll be basically working with your point of contact on your job site, making sure everything is going well. If you have any questions, any issues, I want to make sure that you give me a call so we can get this taken care of for you right away. I'll also be keeping you up to date on the production of your project, making sure you understand where we're at on the project. We've begun making the pipe and we're getting ready to finish. I'll be handling the logistics in the delivery of your pipe, making sure that you're all set. Whatever needs you might need at the delivery site and any sort of concerns you may have, we'll take care of that. I'll be taking care of your invoicing as well. And whatever other questions you might have during the project, I'm here for you for whatever you might need. Also, I said, just thanks for trusting us with your project. Thanks.
Thanks, Tim. So a quick overview agenda of what we'll be covering today. We're going to start out with kind of a Permalok overview. We'll touch on the different joint types that we have, the typical specifications that we see in the industry for the casing pipe, and then also our actual production capabilities at Permalok. Once we get through that, we'll dive a little deeper into the press fit technology. We'll have some further details on the joint designs. We have an efficiency comparison we'll go through. And then we also have some project examples for the various joint types that we'll go through. After that, we have a few joints that we're really super excited about. So we'll get into trenchless innovations, and we'll get to those, later in the webinar. And then we'll close it out with a few slides on our project support side. So the project management approach, Tim, all the things he's involved in, and then finish it out with a Q&A. So like I said, as you have questions throughout the entire presentation, please feel free to throw those in the Q&A. So a brief overview of our locations. As I stated, Northwest Pipe Company rebranded a couple months ago to be NWPX. Our corporate headquarters is located up in Vancouver, Washington. We have six what we call water transmission system plants across the country and one in Mexico. And as you see there, the dark blue dots, they're spread out across the entire country. Um, for precast and engineered infrastructure, we actually have three Geneva plants, all located in the Utah area. They really focus on concrete pipe, concrete structures for drainage, things of that sort. And then we also have our park facilities, three locations in Texas that are geared more towards your, large water meter vault systems and things like that that are precast. But today's webinar highlights the St. Louis, Missouri plant where Permalok is, I would say 99% of Permalok pipe is made at that facility. You got a little marker there showing you that we're right in the middle of the country. So when we need to, we're able to utilize other facilities in the NWPX family. But for Permalok being centrally located, it's fairly easy logistically to get the pipe wherever it needs to go. I am going to start out with a short video here that just kind of is a overview of Permalok. All right, so there was a lot of information and a lot of things happening in that video, which throughout the rest of this webinar, we'll get a little deeper in detail of what you saw there. So for the first section of the webinar, we're going to give you kind of an overview of what Permalok is, the different joint types, and the specifications that we really produce our pipe to. So the first question you can ask is, what is Permalok pipe? So Permalok pipe is a mechanical press fit joint that eliminates the need for welding. Permalok has been in business over 30 years. In 2014, Northwest Pipe at the time acquired Permalok, which was a privately owned company, and that is now the part of the family that Permalok falls under. To date, we have over 4 million feet of Permalok pipe installed in the ground. We have 7 proprietary joint designs currently and always working on new ones. Each project for Permalok is custom built. We're not a supplier who keeps a stock of any size pipe or anything on a shelf waiting to find a project that we can try and fit it into. Every single project that Permalok takes on is a completely custom build from the beginning. One of the advantages to Permalok, when you're installing it and you engage the joint, you do hear an audible pop noise, which is very satisfying for anybody in the field that's putting it in the ground, because it's just a check almost of, yes, this joint is engaged, it's ready to go in the ground, and it really helps people that maybe it's their first time installing Permalok, right? They can hear that audible pop and know time to push pipe. And really the advantage of Permalok pipe versus welded steel casing is it improves the efficiency and really brings down the cost when you're installing a steel casing. So I spoke about the Permalok joints. As I said, we currently have 7 patented or patent pending joints, and they're all designed for a very specific trenchless application. Each one has its own unique characteristic and capabilities that give it the ability to be installed by whatever trenchless method is being utilized. We have what I would call our flagship joint, which is the T5 joint. It's the one that started it all. And the T7, which I'll get into more detail later, is very identical to the T5. Those two joints are most commonly used for a jack and bore application or a microtunneling application. We have our AB joint, which is short for auger bore. Again, I'll get into detail about why it's specific to auger boring and how it works. We have our PR joint, which is designed for pipe ramming applications. We have our HDD joint, which was actually the winner of the 2025 NASTT Innovative Product of the Year, which I'll get to again later in more detail. And finally, we have our RBJ, which is our radial bending joint, which gives you the ability to intentionally curve steel casing in a microtunnel. I've heard of many examples of people using our standard T5 or T7 joint and creating a curve unintentionally, but the RBJ allows you to do it with intention and actually can improve your radius to get a much tighter radius than what standard steel casing can achieve. On top of all the different joints, our steel casing pipe, Permalok, we can do coatings and linings. I know that coatings and linings are very popular in certain areas of the country, and we've also seen in the industry some engineering firms that were typically an oil and gas service engineer come over to the utility side of the business, and they were just so used to having coatings and linings on all their steel pipe that they brought over some of that with them. We typically see for a Permalok steel casing a coal tar epoxy type coating for corrosion resistance. We have many examples of doing that and having success. And typically on the lining side, we'll see some sort of a poly lining that goes inside of the casing for various reasons. With Permalok, one thing that's very important to point out for coatings and linings is that we do not require any kind of a setback. And what I mean by that is if you are welding a plain in steel casing together and you apply coating to the outside, you're typically going to have about 4 or 5 inches of what we call setback from the end of the pipe. That's so when the contractor goes to weld the pipe, they're not having to do their weld on top of a coating or anything. They've got some bare steel there to make their weld, finish it, let it cool off, and then apply the coating to where they've now welded the joints together. With Permalok, because of our male and female press fit joints, there is no setback. You don't have to worry about going in and applying a coating or lining after you've mated the joint. It butts up right up to itself and you're good to go. We do provide touch-up kits for our projects, so things happen in the field, maybe while you're handling pipe off a truck or you're lowering it down into the tunnel shaft. Maybe you get a little ding on some coating or something. We do supply touch-up kits with simple instructions on how to apply those touch-up kits to the coating. And then with our coating and lining, we can provide full inspection reports with certification that the coating or lining was installed properly, to what thickness, how many mils, and all of the information that we can provide to the owner or engineer that wants to see those documents too. So talking about specification, Permalok is a rolled and welded steel plate. It is not a spiral welded coil. We do produce to the ASTM 1097 specification. That is what we typically do. It's kind of our standard. That specification really came to light a few years ago when we noticed that a lot of the specifications in trenchless projects were for the steel casing were specifications that weren't really dialed into a steel casing. They were maybe a carrier pipe specification or some other application. And so it really didn't address the needs that the trenchless industry has for steel casing. I'll get into a little more information on 1097 in a minute. We do have the ability to produce steel casing to the other specifications. We just kind of standardized 1097 as our flag because it's the most stringent, it has the tightest tolerances, and ultimately gives you the best product at the end. Um, as I said, it's a straight seam welded plate that's rolled into a pipe. We then take our male and female rings, whichever joint it is, T5, T7, HGD, and we actually weld those on to each end of the pipe. Permalok did do some direct profiling a few years back, where we actually would roll a can into a pipe and then we would mill in the male and female ends to the actual pipe. And we found that the quality just was not as controlled as making the rings separate and welding them onto the ends of the pipe. So I've got a little chart here that kind of breaks down the different typical specifications that we see in the trenchless industry for steel casing. So the first column there, you'll see 1097, our standard. You'll see A252, A139, and A53. So I want to take you across each row as we go down. You'll see here that all four specifications, when it comes to tolerance on the OD, the outside diameter of the casing, all four are the same, plus or minus 1%. So you know when you get your pipe, it's going to be plus or minus 1% of the actual OD. Now, as we go down, you'll see the differences in 1097 versus the other specs. So when we talk about roundness, how round is your pipe? Is it egg-shaped? Is it perfectly round? 1097 actually identifies that and says it has to be plus or minus 1%. A139 also has this same call out, but you'll see the other two, A252 and A53, they don't even address it. So if you're putting a specification together for a trenchless casing project and you put in 252 or A53, you already know that you're allowing this casing pipe to show up with no parameters for roundness. Now when we talk about end squareness, again, 1097 only allows plus or minus 1/8 of an inch. 252 and 139 don't address it, and A53 just says be square cut, which could be interpreted a lot of ways. Now, when we talk about pipe straightness, which is very important for trenchless installations, especially if you're talking about microtunneling, where you've got minimal overcut, 1097 allows for 0.1% the length of the pipe. You go through the other three, they have phrases like reasonably straight, commercially straight, which again can be interpreted so many different ways. So again, you want your pipe to be as straight as it could be. I tell people all the time, there's so much resources that are put into these projects. And on the contractor side, when I was on it, there are millions of dollars and tons of resources that go into the equipment, the guidance systems, because you want to be as precise as you can be in these installations. Why wouldn't you want your steel casing pipe to be as precise as the equipment and the guidance systems that you're putting all these resources into? That is why Permalok made the decision to make our standard 1097, because we wanted to provide the highest quality product that we possibly could. So at the end of the day, when you look at this chart, it's very clear which one will give you the best quality product. So now Permalok production. As I said, I don't know of many projects over the years that were not produced in the St. Louis facility. Majority of the Permalok pipe comes out of there, and again, we're centrally located, so logistics aren't really much of a challenge for us anywhere in the United States. Our facility in St. Louis is currently capable of producing over 3,000 linear feet of pipe per month. And, as I said, we can utilize all the other plants in our NWPX family as needed. We're actually currently working on some capital expenditure projects that will increase our capabilities at the St. Louis plant and raise that 3,000 linear feet per month number. OD, we can currently produce anything as small as 8-inch in diameter up to 156-inch. And to be honest, the only reason that 156-inch is the largest OD is because anything bigger won't fit through one of the doors in our facility. Wall thicknesses, we can go all the way up to 2.5-inch thick plate to be rolled into a can. I will tell you that we do have a minimum of 1/2 inch, and that's really driven by being able to attach the rings to each end and have the amount of force that you need to install the pipe. Our joint lengths, we can do anything from a 1-meter stick all the way up to a 40-foot long joint, and anything in between. So as I said earlier, Permalok, all of its projects are completely custom, and you could pick any OD in between 8-inch and 156-inch, and we can make it. Even if it's an off number, we've seen 87.25-inch OD. We can make it because, like I said, every job is completely custom. We do not have an inventory of pipe that we're trying to push on to anybody. We created this pretty simple steel casing pipe specification chart, which we can provide to anybody that would like it. We basically just took what are our most common OD sizes and wall thicknesses, and we supply the information of what our recommended jacking load limits are for the pipe, as well as the weight per foot. So I know of a couple engineers already that have tacked this up on the wall next to their desk, and when they're looking at designing trenchless steel casing crossings, they can pull out this chart and have a pretty easy cheat sheet to know some of the detailed information they need for the design. All right, and with that, we're going to dive a little deeper into the actual press fit technology. So starting out with the T5 and T7 joints, which, like I told you, are mainly used for jack and bore applications or microtunneling. They're the most common joints that we see produced and installed in the industry. There's a little video here to show you a little further view of the actual joints and how they go together. So you'll see there, as the joint began to engage, the teeth went over one another until finally locking into place. One other thing that's very important to point out here is once the joints are engaged, you have a smooth OD and a smooth ID. There is no lip from a weld or anything that would cause any problems with your overcut or trying to thread a carrier pipe inside of the casing. So when we talk about the T5 and T7, what's the difference in the two, right? So the T5, our flagship joint, is very simple. It has the male and female ends that connect and create a solid connection where you don't need to weld. What we did with our T7 joint is we basically took the T5 joint and incorporated 2 O-ring gaskets. These gaskets really enhance the water tightness of the joint. Now, I've had many contractors install the T5 joint under a water table and things like that, and no problems at all. But we wanted to have the T7 available as an added insurance, if you will, to make the joint even more watertight. One thing I will point out about these joints, we have had them installed in an open cut application as well. So if you've got a setup where you can get enough push from a track hoe or something similar, you can engage the joints in an open cut environment as well. When I talk about groundwater tables, depending where you're at in the country, that's when we really start introducing the T7. I personally, in my contractor days, have installed T5 joints in just under 2 bar of pressure with no problem, and T7s above 2 bars of pressure. And the biggest thing about these joints, and we keep talking about efficiency, they snap together in under 6 minutes. And I've got a little comparison here I want to walk you through. So if we talk about the efficiency of Permalok, well, what does that really look like? So we put a table together here of a standard 60-inch steel casing installation. So with the Permalok pipe, your connection between joints is made in under 6 minutes, and you can install in a typical 8-hour shift about 10 joints of pipe, so 200 feet. If you are welding together plain in steel casing, a good welder, it'll take him somewhere between 2 and 3 hours to fit up the joints, make his welds, let it cool, have the inspection process done on that joint. So now you're looking at 2 or 3 joints for that same 8-hour shift. So what do you get with the Permalok versus the welded in casing? Well, you get 200 feet per day on one shift, and you get 40 to 60 in the other. It's pretty clear that you almost triple your production by using the Permalok steel casing in that application versus a typical welded plain-in casing. So how does it go together? How do the T5 and T7 joints connect? So all of the submittals that we supply, we even include instruction guidelines of how to install our pipe. We also will come out to your job site at any time and help the crew. Maybe it's their first time putting Permalok together. I myself, Tim, some others on our team are happy to join on the job site and really get the crew dialed in on how it goes together. With the T5 and T7, you basically have one joint. You can see in the picture there that you've already pushed into a certain, footage. You leave a few feet sticking out of the ground. Your next joint is then lowered in the ground from above, and you want to mate up the top of the next joint with the top of the joint that's already installed. What that does is just start to get it lined up. Once you have that lined up, you lower the joint down and get it straight with the already installed pipe. You give it a good push, and you'll hear the loud pop that we discussed to let you know the joint is fully engaged. So for our T5 joint, we wanted to highlight a project here that we did last year. This was the Paris Valley Pipeline I-215 crossing. This particular project installed almost 3,000 linear feet of 120-inch OD Permalok steel casing with the T5 joint. And on top of that, our water transmission side of the business also supplied the carrier pipe of almost 3,000 linear feet, 96-inch transmission line. J.W. Fowler was the Trenchless sub on this project. This project was very crucial to this program because it basically connected 2 separate segments of the Paris Valley Pipeline that had been installed 10 years before this project ever happened. So they had some geological issues, some other items that they were working through, and it took them over 10 years to get everything lined out just to get this project going. And at the end of the day, this segment was able to connect the entire program and allow them to start utilizing it. A couple pictures here. You'll see on the left there, we've got a joint of Permalok pipe being pushed in the ground. You'll see the push ring right there on the end of the pipe butting up against the jacking frame, allowing for them to push the pipe in. The push ring comes off whenever you get the joint installed and just goes right into the next one. And then you'll see on the right there a beautiful picture of a microtunnel machine making daylight, getting ready to be pulled out of the hole and onto the next one. This is a nice aerial view here of one of the shafts on this project where a connection was made. And if you look closely, you'll see some of the 96-inch transmission line pipe sitting there, ready to be lowered in the hole and installed inside of the Permalok casing. So overall, it was a great project for everybody. We really appreciated J.W. Fowler and the whole team for including us, and we were on site for this project for the final hole out. So next, we'll talk about the T7 joint. For this project, it was the Red River Valley Water Supply Project intake tunnel. So anytime you're talking about something that's going to be underwater, that's where that T7 with the O-ring gaskets really becomes the one to involve. This particular project had about 1,600 linear feet of 72-inch Permalok T7 joint. We did actually produce this pipe to the C200 spec, not 1097. And Michaels was the trenchless contractor on this project. Um, the real need for this one, they were pulling water out of the Missouri River and taking it across about a 167-mile pipeline to various communities all throughout North Dakota. We not only supplied the Permalok pipe for this intake tunnel, but we actually supplied some pretty cool looking specialized fittings, which I have a picture here of. You'll see some of the fittings there that made certain connections at different points throughout the project. We were able to work with the contractor on that as well because of our capabilities with all of our different facilities throughout the U.S. On the right there, you'll see one of the retrieval shaft that was built in the actual Missouri River. And then finally, here's a picture of the Permalok pipe that was coated and lined with a poly lining and a poly coating going into the ground inside the shaft. Okay, our next joint I want to talk about is the Permalok CC joint, which stands for cycle casing. So when we think about auger boring and pilot tube guided boring, many times if you're using those installation methods for a larger casing, say a 60-inch, you'll do what's called a cycle. So you'll shoot your pilot, which is about a 4-inch OD pilot tube. You'll do what then we call a cycle of a 24-inch or a 30-inch or something in that ballpark, where you want to chew off some of the excavation that you're going to have to do to get to 60 inches. Well, historically, you've had to do that with plain in steel casing that you weld together. And then as you get that, next size up installed, call it a 30-inch in this example, when you get ready to go behind that with your next step up, whether it be 48, 54, 60, you push that 30-inch casing out of the exit pit as you install the larger diameter behind it. Well, when you do that with a welded casing, you then have to torch it, cut it, remove that steel casing from the exit pit as you advance, and that casing takes a lot of work to be able to be used again. So at Permalok, we decided we've got a solution for that. So we created the CC joint to really be able to be used as a cycle casing that you don't have to weld together, and you also don't have to torch it or cut it on the exit side and basically ruin the casing. You can pull it apart on the exit side and reuse it over and over and over again. So it's really designed to be kind of a slip joint install for a stepping up process. And that transitions straight into our AB joint. So our auger bore joint, because of the nature of an auger bore install, you can't really install it the same way you can a T5 and T7. If you remember, I said when you're installing those T5 and T7 joints, you want to line up the top of the joint first and then lower the pipe down to get it straight and then push. Well, with an auger bore, you're preloading your casing with auger, which you can see in that photo on the left. You can't bring it down at an angle, try to snap it together, because then you can't make your auger connection. So what we did, if you were standing next to a pipe that had an auger bore male end and a T5 male end, you would notice that the auger bore joint actually has a longer profile than the T5 does. The reason we did this is to allow it more space there for the joint to find itself and push in a straight push installation manner, not have to come down at an angle. And we also found that with the longer profile, it reduced the jacking force needed to actually engage the joint. Typically with an auger bore joint, you'll see about half of the push force that it would take for a T5 or T7 to fully engage it. It's a fast, effective solution for installing the auger bore casing. And, everything that we do is about reducing cost, being faster, and increasing efficiency. So now let's talk about some of the trenchless innovations that we have. Some of the things we've been working on or are working on that are exciting. So I'm going to start this out with the Permalok PR joint. The purpose of this was to allow the energy transfer that's necessary for a PR install to move across the joint. We had some contractors before this joint was available that would take our standard T5 joint and try to pipe ram it. And what they found was at the actual joint where the male and female ends meet, there was a significant energy loss. The energy was not transferring from the pipe ram machine all the way down the string. So what we did, our extremely smart engineers found a way to design a joint, which you can see a picture of it right there, with that curvature in it that allows for the energy transfer to happen. It can take the brute force of the pipe ram installation process, and we do provide push rings that go up against the pipe ram machine that fit up to our pipe, which allow you to then move from one joint to the next. Some of the projects that we've done with the PR joint to date, this year alone, we've done 3. We have more slated. Again, it's a Permalok joint. It snaps together in under 6 minutes. And we can make this joint like any of our other pipe, anywhere from a 1-meter stick up to a 40-foot joint. I will point out as well, I am currently in Salt Lake City for a pipe ram job that starts tomorrow with BT, where we will be presenting at the No Dig show next year on this particular project, and we will have a bunch of data collected on the efficiencies of the PR joint and how well it installs. One other thing I want to point out too with the PR joint, it can be used for conductor casings. Anybody that's been involved with horizontal directional drills or anywhere else where a conductor casing was necessary, you can utilize the PR joint for the conductor casing install, which also cuts down on time and cost. So with that is a perfect segue into horizontal directional drilling. So I've got these pictures up here because I want to show you a typical pipe string out for a steel casing HDD install. Some of these things are thousands of feet long, and you'll see on the picture on the left there, sometimes you don't have the room you need to string out 4,000 feet of pipe. So then what you find is you've got cost there. You can see traffic control that's set up, closure of a lane. You've got shipping containers to raise up those pipe rollers to get them to the height they need to hold the pipe. You've got all the pipe rollers there, and you've got this thousands long string of steel pipe out there in the middle of a busy road. On the right side, you'll see some cranes set up with cradles, because as the steel pipe reaches its entry point into the ground, you actually have to raise that steel pipe in the air and do what we call a breakover to get it at the correct angle to go into the ground. Well, steel pipe doesn't really bend that well if you compare it to a poly pipe or other different types of PVC and things. The bending radius for steel is not anywhere near as tight as those other pipes. So you have to have these cranes and these cradles to raise it up in the air to get it to the proper entry angle. Well, not anymore, because with the Permalok HDD joint, you don't need any of that. The HDD joint is a direct push joint system specifically for horizontal directional drilling. It eliminates the need for a pipe string out, any welding, and all the additional equipment that comes with it. It reduces the project footprint and all the associated construction cost. It utilizes a direct push to engage the joints rather than pulling technique, which is traditionally used in HDD. It provides the same allowable bend radius as a standard HDD installation, which is about 100 feet per OD inch. So we basically said, you've got this maxi rig that can pull over 1 million pounds of force. Why can't you push with it? And so we did all kind of internal testing to design the joint and found out, yes, you can push with it. And I have the perfect example of doing this. The Champlain Hudson Power Express project happened last year. I'm sure a lot of you have heard of the Champlain Hudson Power Express program, but we were specifically on one portion of it with Michael's Trenchless. We actually installed over 10,000 linear feet of 20-inch steel casing. It was two drives side by side, 5,200 linear feet each. And this project actually, we found out recently, won the Trenchless Technology 2025 Project of the Year. So here's kind of a bird's eye view of this particular section. You'll see there on the launch side, that is where Michael set up their launch rig, and that is where the Power Express facility is. On the exit side, crossing the East River, you'll see it's kind of a park setting with baseball fields, soccer fields, things like that. But if you take that green line that you see there, which was basically the plan view of the crossing, on neither side do you have enough room to string out an entire 5,200 linear foot string of steel casing. Here lies the problem. So Michaels came to us, we worked with them through a redesign to utilize our HDD joint to get both of these casings successfully installed under the river. You'll see here on the launch side, the maxi rig was raised up for the installation entry angle. They had pipe staged right next to the rig, ready to go, so as they installed a section of casing, they could load the next one in. On the exit side there, you'll see a smaller rig that really was only utilized to remove the trail stem that they had, the pilot stem. And what we found during install was they were putting a new joint of pipe up, connecting it, and ready to push faster than they could remove pilot stem on the exit side. So how's the joint connection work? Well, you'll see there on the left, the only equipment modification needed was a clamp system to hold pipe that had already been installed for, I'd say, the first 400 or 500 feet. Once they got past that mark, we found that the friction underground actually held the pipe in place well enough to where they didn't even need the clamp anymore. So there you'll see they're fitting up the new joint to a joint that's already been pushed, what the joint looks like completely together. And I've got a short video here showing you how long it took to get the pipe actually together. So I'm sure you heard the audible pop there that I've been talking about. That's what let everybody know, okay, it's together, we can start pushing. The last joint that I want to talk about in our innovations portion is the one we're probably the most excited about, our Permalok radial bending joint, or RBJ. If you've heard any presentations we've given over the last couple of years, we have been talking about this for a long time. But I got good news. We've got two jobs going in the ground early next year with it. It is the first steel casing designed to intentionally curve a microtunnel. With that, you can eliminate shafts along tunnel alignment. It gives you the flexibility to start and finish tunnels where it warrants. There is no set radius for it. We do look at it on a case-by-case basis. But I can tell you we were recently looking at a project of a 78-inch OD casing, and we were able to get that radius down to 2,500 feet. The magic that I would say in the RBJ is the ability of the joint to distribute the load across the entire joint as it is installed. It does not point load at any particular section of the drive. And as I said, we've got one project being installed late January, early February next year with the RBJ, and another one slated up in May with Northeast Rimsco and Huckstead. I do want to play a short video here for you of the actual RBJ process.
And Brian, feel free to walk us through the process that we're seeing here.
Sure. So they're advancing the machine, coming up on a subway crossing where they're going over the subway. As you'll see here, they jack in one joint of casing, load the next one, and as you'll see right here at the subway, they're actually making the curve to go around various utilities, other things that are in the ground to get to the exit shaft right there. And you notice there's people walking, there's cars driving, there's all kind of stuff going on above ground, but you're able to utilize the RBJ technology to make that curve and get a path to the exit shaft and get the casing installed. So we're really excited about the RBJ. We've got a couple jobs coming up. We will be doing papers on those next year once we have them in the ground as well. So the last section here I'd like to talk about is our project support section. We do have design assistance, and what I mean by that is we want to work with owners and engineers and contractors from the very beginning of projects. We do have in-house engineering to review alignments and look at jacking forces, see ground conditions, and really help an engineer or an owner or whoever look at a project up front and say, yes, this works because of this, or it doesn't because of this. We have both steel pipe and concrete jacking pipe expertise. We're able to provide recommendations on sizes or wall thicknesses or strengths. We've got over 20 years of past experience in the field with installation methods that we can utilize to help with the design. And we really feel like the more collaboration that there is in the trenchless industry up front, the better a project can go both through the bidding process and the construction process. Let's bring the suppliers, the engineers, the owners, and the contractors all to the table up front and really have a better product in the end for everyone to have a successful project. The next piece is our project management approach. I am going to ask Tim to come on and talk through this slide.
Okay, so from the minute Brian hands over the project submittal to us, or basically the quote, I take it from there. So I'm going to basically get some details from your point of contact, trying to get an idea of how you want your drawing set up, your plates or your certs for your job, any orders to other needs that might need to happen to get this onto final submittal to your engineers. I'm also basically going to be handling a lot of the scheduling with our plant managers and our plant supervisors to make sure when we can get your product into the production as soon as possible. If the time is basically hurry up and we need this right away, or we have a little bit of time, we can kind of adjust to your schedule however we need to do. Open communication is always going to be a high priority for us. So I'm available basically by text, email, phone calls, whenever you might need. Any flexibility that might be needed with you guys, please just let us know, and we will basically do anything and everything that we can to make sure your project goes as smoothly as possible. And then the customization of everything, just whatever you might need us to do to make sure that all your needs are taken care of. Delivery ends, any sort of special instructions needed on submittals and drawings, we're going to be there with you from the very beginning of the project to the very end. We want to make sure your project goes as smoothly as possible and make sure that you continue to get business.
Thanks, Tim. Yeah, Tim has really taken ownership of the projects from the project management approach, and we've really, as a company, tried to take this very seriously because we don't want to be just a supplier of pipe to, anybody. We want to be a partner in these projects. We want to work with you, and we want to make sure we're doing what we can to help everybody be successful. We do have a whole team of people, like I've said many times. You obviously have listened to me blab on for almost an hour. You met Presley earlier. You've heard Tim talk a little bit. But I do want to point out our operations manager, Bill Cason, is extremely good at what he does. He's in charge of the entire operations side of things. He's traveling to job sites. He's helping with installs. He's answering questions as he needs to as well. And Jeremy Howard, our plant manager, has done a tremendous job running the plant, the day in, day out things, all the crews that are producing the pipe. And Jeremy actually spent a few years, I think 3 to 5 years, on the commercial side of our business. So he understands the commercial side as well and has a lot of great relationships with our customers. And that's how we want it to be. We want our customers to want to work with us, not just because we have extremely quality pipe, but because we're going to do everything that we can to make sure they're successful. Same goes for owners and engineers. We want the phone calls of, I think I'm designing a job that has this. What do you guys think? What have you done in the past? What's worked? We want those conversations. We want those teams meetings. We want to get our knowledge and our information out in the industry to make it better as a whole. So with that, that's all I had to do presentations on. I'll open up the questions area here and let Mark kind of moderate it for us.
Yeah, thank you, Brian. One that came in, the presentation states the T7 has O-rings. Are the other options not watertight or just to a lesser extent?
So we've had many customers install our casing that wasn't a T7 that had no issue with water tightness. It does come down to how well the installer connects the joint, obviously. But again, the T5, I've personally installed it under over 1 bar of water table and had no issues with water infiltrating inside the joint. So it's a combination of, yes, the joint is leak proof, but it has to also be installed properly too.
And I guess a continuation to that question, depending on the answer to one, what are the sealing surfaces of the joints?
So one thing that I did not touch on, when we provide our casing pipe, we do provide a silicone sealant that, number one, when you apply it to the male and female joints, acts as a lubrication for the joint to snap together. But then once the silicone sealant dries and hardens, it actually helps prevent any kind of infiltration of water or drilling mud or anything like that. That does get it put on all of our joints.
Got it. Thank you. This one is about deflection. So you mentioned that some contractors have deflected on non-RBJ joints. Is there published allowable deflection on these joints?
We typically, if it's not the RBJ, we will only allow for up to 1 degree of deflection on the joint to make sure that you keep the integrity of the connection intact.
And we saw those photos of fittings for the Red River Valley project. So regarding the fittings, including the Y that we saw there, are there any concerns with push forces applied on the joints of the fittings?
The fittings weren't necessarily pushed in behind the casing. They were applied after the casing was installed to make different connections. So they were not pushed in the ground with the same equipment as the microtunnel.
Perfect, thank you. A question about, can these casings be used at fault crossings? More specifically, what type is best for active fault crossings, and what type of deflections could it handle over the lift of the product?
So we actually are in the process of reviewing our joints for fault crossings. We're looking specifically at the RBJ. I will tell you that when it comes to the carrier pipe, our water transmission side has a new product, the InfraShield product, that is designed specifically for fault crossings and being able to have a steel transmission line go across them without the fear of something happening at the fault and it separating. I believe, Mark, correct me if I'm wrong, they're doing a webinar on December 11th specifically on the InfraShield pipe, which is utilized at fault crossings. Am I right?
That's correct, yes.
Okay, so
That's our next one on InfraShield. The focus is a lot about differential settlement applications, but we do cover a large transmission project in the Houston area that's using the InfraShield specifically for fault crossing application. So yeah, if you have interest in that area, definitely join us on December 11th. And I can include the link to register for that webinar in our post-event email that I'm going to send out to all of our attendees today. So Brian, thank you so much for the presentation. Thank you, Tim and Presley, for the support. Any final words, Brian?
No, I just want to say thank you again to everybody who logged in today. It means a lot to us, with it being our first one. I hope you learned something. I know it was a lot of information in just an hour. Feel free to reach out to me, email, call, text, any questions you might have, or maybe something you wanted more clarification on. I can't thank everybody enough. We have great people that we work with. We have a great internal employee, company, and we love what we do and we want to do more of it and we want to help however we can. So please feel free to reach out with anything else you might have.